All right, guys, this is Ms. O'Neill. I think Mr. Baker and I are just going to alternate days on making videos. So I am not going to start us off with any terrible jokes, especially COVID virus jokes. So I don't know. Some of you guys will probably be disappointed by that, and some of you guys will probably be just fine without the jokes. So we are going to continue talking about graphs of exponential growth and decay functions. And specifically, we're going to talk about some transformations of those graphs. So our essential question is, how do you transform the graphs of exponential functions? So let's go back to our basic parent function that Mr. Baker talked about the other day. F of x is equal to b to the x power. Oops, I don't like the way that looked. There we go. Okay, if we are making that basic parent function have a vertical reflection, do you remember from all of our graphs this year, what would make that graph flip upside down? What would make a vertical reflection? Hopefully you said if we put a negative sign in front of our function. So maybe we'll put that base in parentheses, that negative sign out in front would make a vertical reflection. Do you remember how to make a vertical stretch or a vertical shrink? If we are making a vertical stretch, then we're going to put a value a out in front of the function as long as a is greater than 1. If a is a value that is bigger than 1, then a times b to the x power would make a vertical stretch of that exponential function. And if we wanted to make a vertical shrink, how would we accomplish that? The negative sign out in front, remember, makes a vertical reflection. So to make a vertical shrink, we're still going to use that value a, but a is going to have to be a value between 0 and 1. If a is between 0 and 1, a fraction between 0 and 1, then it will make a vertical shrink in our graph. And we are not, for these exponentials and logarithms, going to worry about horizontal reflections or horizontal stretches and shrinks, because those are a little difficult, and we really needed to narrow our focus down with this continuous learning. So we're just going to leave those out right now. We are going to talk about horizontal and vertical translations, though. To make the graph shift up or down, a vertical translation, we would, we don't need an a this time. We would put outside of the function a value of k. Adding a value of k outside of the function would move the graph up or down, make a vertical translation. And so a horizontal translation would happen if we put a value inside the function. And by that I mean inside the exponent with the x. If we made our function b to the power x minus h, then we are going to shift our graph left or right. And remember, because that negative sign is built in, it's going to shift the opposite way that we think it is. So I always say when it's inside, it does the opposite. I think Mr. Baker says when they're inside, they're dirty, dirty liars. Whichever way you remember it, that's going to be the opposite of what it looks like. So let's try to, just from some equations, and I didn't mean to have that equation in there. I deleted it on my other slide, but then I forgot on this one. Let's describe the transformations that are represented when we've got f of x, our basic parent function. F of x equals 2 to the x power. And then when g of x, we add in that plus 1 and that minus 3. Let's see if we can figure out what those do to the graph. So if we put a plus 1 inside the exponent, remember those inside things do the opposite, that is actually going to move my graph left 1 because it's a positive 1. So it's actually going to move it left 1. Really, this should be x minus a -1. And so that -1 is moving it left 1. The +3, or sorry, the -3 on the outside is going to do what to the graph? Yeah, that's going to move it down 3. And so what about for number 2, where we've got that basic parent function f of x equals 3/5 to the x power, and we instead put a negative sign out in front? What does that do to the graph of our exponential function? Yeah, that's going to make a vertical reflection. So it's going to flip the graph upside down. And finally, for number 3, what happens if we put this 1/3 in front of our function? What is that 1/3 going to do to the graph of our function? Because it's in front, I know it's going to be a vertical stretch or shrink. And because it's a fraction that's between 0 and 1, its value is between 0 and 1, then I know that is going to be a vertical shrink by a factor of 1/3. Okay. Just for fun, can we also decide if these are exponential growth or exponential decay functions? Because that's still something you should know how to pick out. So in number 1, because the base of my exponential function, the thing that's holding up the exponent, is 2, then I know that this function, because that base b is bigger than 1, is going to be an exponential growth. And so then if I look at number 2, because our base, 3/5, that value b is between 0 and 1, it's not bigger than 1, then this is going to be a decay function. And for number 3, our base is again 2, just like it was in number 1. So this is going to be another growth, exponential growth function. You should still be able to pick those out. All right, so now let's look at what the graphs of these will actually look like. So for this should be number 4. Somehow I grabbed the wrong slides when I was pulling this one up. So let's see. If this is number 4, then for number 4, we've got the function f of x equals 1/3 to the x plus 4 power minus 2. So I notice that the base of my function is 1/3. I'm going to go ahead and graph the original parent function of just f of x equals 1/3 to the x power first, and then I will do the transformations on it. So as Mr. Baker showed you the other day, usually you just use a little XY chart or an f of x chart. And you plug in, -1, 0, and 1 for your x values. And so if I do that, 1/3 to the negative first power would flip that fraction over, right? Negative exponents make reciprocals. And so I would have a y value of 3. And then 1/3 to the 0 power, anything to the 0 power, is 1. And then 1/3 to the first power obviously is still 1/3, and so I can graph those points, -1, 3, 0, 1, and 1, 1/3. You remember those basic points for your exponential graph? It always includes that ordered pair 0, 1, and then 1b, whatever your base is. So that ordered pair 1, 1/3. And then we also need to draw in the asymptote for this graph. So we have an asymptote right there on the x-axis for the parent function. And then I'm going to draw my exponential growth curve, exponential decay curve like this. But that's not going to be the whole function. The whole function really is if we put on that +4 and that -2. So let's think about what those are going to do to the graph. that plus 4, because it's on the inside, is going to do the opposite of what it looks like. It's actually going to move the graph left 4. And that minus 2, because it's on the outside, does exactly what it looks like. It's going to move my graph down 2. So I'm going to take each one of these points that I graphed before and just move them left 4 and down 2. So I'm going to take this point that's at negative 1, 3, and I'm going to move it left 1, 2, 3, 4, and down 2, 1, 2. So my new point lands right there. I'm going to take the next point that was at 0, 1 and move it left 4, 1, 2, 3, 4, and down 2, 1, 2. And then I'm going to take that next point that was at 1, 1/3 and move it left 4, 1, 2, 3, 4, and down 2, 1, 2. It's going to be about right there. And then my asymptote would also move left 4, but that I can't tell because this asymptote goes on and on forever, but I can see when it moves down 2. So my new asymptote is right there at that line y equals negative 2. And then if I try and draw in my exponential decay curve, it would look something like this. I'm trying not to make it look like I crossed that or the line y equals negative 2, because I don't. You get closer and closer and closer to that asymptote, but you never quite cross it. All right. So now if we talk about domain and range, just like the parent functions, the domain is always going to be all real numbers. Those x values can go left forever and right forever. We can put in negative numbers for x, but the range will not, because it never, ever, ever gets quite to that asymptote. So our range for this one is going to be where y is strictly greater than negative 2. Because the graph is starting down at negative 2, or really, really, really close to negative 2. It doesn't actually quite hit it, and only goes up from there. So y is greater than negative 2. All right, let's look at number 6. What is going on with number 6? I'm again going to start with just the basic parent function. And so I'm going to graph g of x equals 2 to the x power first, and then I'll deal with that 1/3 outside next. So if I again make my basic XY chart with my x values of negative 1, 0, and 1, then my y values would be 1/2, because a negative exponent makes it a reciprocal, 1, anything to the 0 power is 1, and 2, because 2 to the first power is 2. And so I can graph those points. Negative 1, positive 1/2, 0, 1, and 1, 2. If you wanted to graph another point, then I could do a 2 in there. 2 to the second power would make 4. I could put a 3 in there. 2 to the third power would make 8. And so I could graph 2, 4, and 3, 8 if you just wanted a couple more points to see how that curve is looking. And then again, I need to graph that asymptote would be right there on the x-axis for the parent function. And so my curve will look like this. That is an exponential growth curve, getting bigger, going up as I read the graph from left to right. Okay, but we really don't have that equation. We have this equation with the 1/3 in it. So what is that 1/3 going to do to my graph? Yep, that's going to be a vertical shrink by a factor of 1/3. So this point that was at negative 1, 1/2 is only going to be 1/3 as tall. So 1/3 of 1/2 is 1/6. That's going to be really hard for me to graph right there. The next point that is at 0, 1 is only going to be 1/3 as tall. 1/3 of 1 is 1/3. So it's going to be about right there. My next point that was up at 2, if I multiply that 2 by 1/3, 1/3 is tall, vertical shrink by a factor of 1/3, 2 times 1/3 would be 2/3. So my graph would be at 1 and 2/3, about like that. That's kind of hard to graph with just those 3 points, which is why I thought we should go on and graph just a couple more. So if I do 4 times a third, I'd be at 4/3. So I'm at 2 4/3. And 8 times a third would be 8/3. So I would be at 3 8/3. Let's see, 8/3 would be 2 2/3. So 1, 2, and 2/3, like that. And my asymptote, because it didn't move up or down any, is still going to be on the x-axis. I'm going to draw this one just below the x-axis so maybe we can see that green show up. And then I'm going to draw in this exponential growth curve. Like this. So that 1/3 was a vertical shrink by a factor of 1/3. And so then let's talk about domain and range for this one. The domain is going to be all real numbers still. They always will be all real numbers for exponential functions. And the range is going to be just what it was the other day. It's going to be y is greater than 0 because my asymptote is on the x-axis and my graph is only going up from there. Okay. All right, let's try just a couple more. Let's see, that was actually number 5. So let's look at number 6. For number 6, they gave us f of x equals -2 times 3 to the x power. So again, I'm going to stick with just this basic parent function and graph y is equal, or f of x is equal to 3 to the x power. And so my basic points would be at -1, 1/3, 0, 1, and 1, 3. And I'm going to take those points and do this transformation. So the transformation says that we are going to multiply those y values by a -2. We've got 2 different things going on there. We've got a vertical reflection and we've got a vertical stretch by a factor of 2. So our x values are going to stay the same. We're still going to use -1. But instead of having a y value of 1/3, we're going to multiply that by -2. So our y value is going to be -2/3. And instead of having our point at 0, 1, our y value of 1 multiplied by a -2 is going to be 0, -2. And then for our point that's at 1, 3, we're going to multiply that y value 3 by a -2. So we're going to be at 1, -6. Our asymptote did not move up or down at all, so it is still there on the x-axis. And my graph looks like this. It is upside down this time because we had a vertical reflection. Okay, so then let's talk domain and range on this one. The domain is still all real numbers. It goes left forever and right forever, but the range is going to be a little different this time. This time our graph doesn't quite reach the x-axis, so it doesn't quite hit 0, but it's only going down from there. So this time our range is going to be y is less than 0. And so for this last graph, if I do that basic parent function as g of x equals, to touch theory, 1/4 to the x power, then I would have points at -1, 4, 0, 1, and then 1, 1/4. But I'm going to do a couple things to the graph this time. I'm going to multiply, oh gosh, I keep doing that, multiply the y value by -3, and I'm going to add 5. Those are both happening to the y, and I just follow my good old order of operations, PEMDAS, please excuse my dear Aunt Sally. And so I'm going to do those in that order. I'm going to multiply the y value by a -3, and then I'm going to add 5. So for my first point, I was at -1, 4. That y value of 4 is going to get multiplied by a -3, so that would put me at -12. And then I'm going to add 5, so that's going to put me at -1, -7. My next point was at 0, 1. I'm going to take the y value 1, multiply it times a -3. So that puts me at -3, and then add 5. -3 plus 5 is 0, 2. And that last point that was at 1, 1/4, I'm going to take that 1/4 and multiply it times -3, so -3/4, and then add 5. So -3/4 plus 5 would be at 4 and 1/4. So 1, 2, 3, 4 and 1/4 right here. And that asymptote that normally is on the x-axis is going to move up 5. So my asymptote is going to be right here at the value, at the, with equation y equals 5. Like this. And then my curve is going to look like this. Ooh, that is really steep. Hard for me to draw on my iPad. Okay, there we go. All right, and so my domain is still all real numbers, but the range this time, it's going almost to 5, but it's going down from there. So our range is going to be y is less than 5. So today's assignment is going to be an IXL. Hopefully your teacher has already sent you your login to IXL. It's going to be matching exponential functions and graphs. I am going to, for my Google Classroom, just make a direct assignment in Google Classroom that should link exactly to the IXL piece of matching exponential functions and graphs. But if for some reason it doesn't, you can just open your IXL account and go to Algebra 2 and then find matching exponential functions and graphs and go through that. And it should save your grade in there for me. The matching is going to be a little bit easier than what I was showing you guys in the notes because you are literally just going to match the graph and the equation. And they didn't do any horizontal translations at all. So it's just vertical stretches, shrinks, reflections, and vertical translations. So good luck on this, and I look forward to seeing you guys again online soon. Take care. Stay safe.